Hello everyone, this video is about numerical solution of equations past paper. So let's say we have this question, the part I is about integration. So let's just do part II and III. Verify by calculation that I lies between 3 and 3.5. So look at part I, you have the equation A equals 2 ln A plus 2. If you move everything to the left, you get this. And to find the function, it's gotta be something equals 0. So the function is actually the A minus 2 ln A plus 2. And you plug in 3.5, and you'll get something negative, something positive, and draw a conclusion. Sign change exists, therefore A lies between 3 and 3.5. So you have to write down the conclusion like this. And now for the part III, use an iteration based on the equation to determine a two decimal places. Give the result of each iteration to 4 decimal places. So for the A naught, for the first value, we use exactly in the middle between 3 and 3.5, which is 3.25. And this is what you do in your calculator. You plug in 2 ln 3.25 plus 2, put everything in your calculator, hit the equal sign, and you'll get this value. And for the next steps, just go back and replace the 3.25 with the answer button and keep pressing equal sign. When you press the equal sign, you'll get this value and so on. So you have to write the values in 4 decimal places. You have to follow the instruction here in 4 decimal places, round off carefully, and we stop when we have three same values here. So we have 3 exactly the same values in a row in 2 decimal places, because we only need up to 2 decimal places. 3.36, therefore the answer is 3.36. You can stop writing the iteration here. And just to check, you can keep pressing the equal button in your calculator until the displayed number doesn't change, and you'll get this value. So this is just to make sure that the function or the iteration converges and that you are not making like a mistake. Maybe you use this value, which is like 3.35, and that's actually wrong, because the final value is 3.36 actually. Alright, yeah, for the next question you can just try on your own because it's similar, also similar. Okay, let's check out this one here. So we have this graph, we have the function, and we have two x-intercepts. Find the value of b. So to find the value of b, this means we need to find an x-intercept. B is an integer. So here for the first part, we use the rational root theorem, if you still remember. So the possible root would be the plus minus factors of the trailing coefficient divided by the factors of the leading coefficient, which is 1, so 6/1. So the factors of 6 can be 1, 2, 3, 6, and divided by factors of 1 is just 1, so plus minus 1, 2, 3, 6. And from the graph, actually, b is on the right side of the y-axis, so it of course cannot be negative. So you don't have to try the negative ones, just try the positive ones, 1, 2, 3, 6. If you check using the factor theorem, so you can plug in 1, plug in 2, plug in 3, plug in 6, and actually when you plug in 3, you will get exactly 0. When you replace the x with 3, you get 0 exactly. So that means the 3 is a root, so therefore the b is 3. Part II hence show that A satisfies the equation. Okay, so you can always just multiply both sides by -3 and rearrange, and you see you get like something in a to the power of 3. So the highest power is a to the power of 3, which means we're not gonna use this one. So we're gonna have to do like long division. The original function is the dividend, and we divide by the root because the root is 3. Of course the factor is x minus 3, so we divide by x minus 3, and we do the long division, and we get this quotient, and this means the original function equals x minus 3 times the quotient. And since the b is the solution from this factor, so a must satisfy the other factor here. So a satisfies this, so this equals 0, and from here you can move this 3e to the right, and you can divide by minus 3. You get what you need to prove here. A equals minus 1/3 times, exactly the same. And for part 3, use an iterative formula based on the equation in part II. So of course this is the equation, so it's given in the question. We use this as the iterative formula in 3dp. So this is the iterative formula. For the first value, just look at the graph, so estimate from the graph. So obviously it's on the right, so it's something positive. Wait a minute, are we looking for, all right, we're looking for a, so the one on the left. So it's something negative. You can use maybe -1, -2, -3, just use something negative. So since although this is not drawn to scale, but we know that the b is 3, so this might be something less than 3. So let's just try -1 or -2. So if you plug in -1, you will get this value. So in your calculator, you replace the a with -1, so -1/3 times 2 plus 1 squared plus 1 cubed, you get this. And then you can from the calculator, you go back and replace the number 1 here. You delete the number 1 and you press the answer button, delete 1, answer, and you'll get this value, 0.71605. And now you just have to press the equal button. Just press the equal button again and again, and you get this value, this value, this value. Write it down, round off to 5 decimal places, and as you can see here, we have consecutive same number in 3 decimal places. So this is enough. You can draw a conclusion. You don't need to keep writing. This is enough. And with your calculator, you can keep pressing the equal sign until the displayed number doesn't change anymore, and you'll see you get this. This is just to check, to make sure our answer is correct, and to make sure that the function or the iteration converges. Right, then here we have another example. We are given the iterative formula and we are given the initial value, so we just have to plug in. The initial value is 2. You plug in 2 like this, 2 2 2, you get this value, and then you go back, replace it with the answer button, you get the next values, and therefore in conclusion, in 4 decimal places you get the answer. And for the next step, state an equation satisfied by alpha. So from the iterative formula, you just ignore the n plus 1 and the n here. So we have x equals 2x to the 6 plus 12x all over 3x to the 5 plus to the 5th plus 8. And you can like cross multiply, and then you simplify, and if you solve the equation analytically, you get 0 and the square root of, the 5th root of 4, and the answer would be this one here, because obviously it's not 0 here. Alright, and yeah, for next question, I think it's also similar. This one, yeah, it's again similar by reading the graph first. Right, just read the PDF on your own. Alright, I'll see you again next time.